In this example, we're going to connect algebra and geometry. And for A, it says set up an equation. So this should be just an equation. And solve for Z. So we got a variable Z here. And then find the length of AB. Alright, so we need to solve for the variable and then find the length of one of the sides. Let's look at the diagram. We've got some expressions here for the side lengths, and we also have some congruent tick marks. So this one happens to be an equilateral. We can set any of these expressions, which are just the lengths of the sides of the triangle, equal to each other. It's whatever one you think would benefit you. I think 3z equal to, I'm going to do a little line there, equal to z plus 4 is going to be pretty easy to solve. But you could do z plus 4 equals 15z minus 24, or you could do 15z minus 24 equals 3z. Anything like that's fine. In this case, at least. So we've got 3 minus 1, which is 2. There's a z there. Those guys are gone, and we've got a 4 left. We'll divide by 2, and z will be 2. If we think about this, we've got 2 plus 4, so the side length would actually be 6. 3 times 2 is also 6. And then 15 times 2, which is 30, minus 24 is also 6. It's a good idea to check your work here. We have tick marks here, so these sides have to be congruent. Their measures must be the same. And if you made a math error somewhere in here, an algebraic mistake, you can pretty much easily figure it out by substituting it back in. Be aware that when you plug it back in, you might have made a mistake there too. So try to look for that mistake wherever you can find it. We've got z is equal to 2, that's the variable. We want to find the length of AB. So we can state that just AB here is 6. Remember, don't use the line segment on the top if you're talking about the measure. Part B, we need to set up an equation and solve for x. Then we're going to find the length of AC. If we look at our tick marks here, we've got congruent tick marks on these two sides of this triangle. This one's going to be an isosceles, I believe. And what we'll do then is we'll take the measure of this side and set it equal to the other side. So we've got 7x minus 25 equals 3x minus 1. We'll subtract 3x from each side. We've got 4x minus 25 equals negative 1. We'll add 25 then. And we've got 4x is equal to 24. Divide by 4, and x will be 6. Now, you might think you're finished, but in this case, you are not. So what we need to do is be very, very, very careful about reading directions. This says set up an equation. Got it. Solve for x. Done. Then find the length of AC. Not finished yet. So what we'll do is we'll take AC here and we'll substitute in the value of x we think will work, and that's a 6. So this will be 42 minus 25, which is 17. So we could write AC is equal to 17, and that's part of the problem. Now we could check our work in this case pretty quickly. We've got 3 times 6 minus 1. So 3 times 6 is 18. 18 minus 1 is 17, so our value of x works, and we verified that AC and also AB are 17.